Welcome, Calculus BC. This is lesson 3.3, graphing derivatives and antiderivatives. Let's begin. So what we're going to do is we're going to use a graph to create the derivatives of the graph, or maybe even go backwards and create antiderivatives of graphs. So we kind of use what we have from the graph to make some estimates and make some judgment calls here. It doesn't have to be perfect, but we look for some key terms. So let's, for example, I have this is a graph of f, and this is the derivative of the graph. I want to sketch a rough idea of what the derivative would look like. So I look for key parts in the original. Now I know derivative is just going to be the slope of the original. Well, I know right here at these relative mins and maxes that the slope's going to be 0. So I know when x equals 2 is slope 0, so I'm going to put that point in right here. And then down here, so it's negative 2, and then positive 2, we also have a slope of 0. That's like those relative mins and maxes. So I know those 2 points exist in my f prime graph. Now, the area to the left of this relative max, this is all a positive slope right here. I know it curves. So that means my f prime graph must be positive. That means the y value must be positive. So I'll say, hey, it's starting here. It's going to be positive, and it's got to go to this point. So maybe it does this. I don't know. And from this point to here, we have a negative slope the whole time. So I know my f prime graph is all going to be negative y values, and it's got to get to this point, so maybe it does this. And then over here, we're positive, so my slope is positive, so I know my f prime is going to be positive y, so maybe it does this. And so here's a rough sketch of this is f, and this is f prime. So you're looking for some key parts that you know. And then you give the rough sketch. Is this perfect? No, but good enough. Now, a few things just to help you out here. We want to sketch, this is good notes right here. If I had a graph that was the first derivative was positive and the second derivative was also positive, what does that kind of stuff look like? So we're just going to sketch out all 4 of those ideas. Now, the first derivative is positive. That means my slope is positive. And if the second derivative is positive, we are concave up. So what part of the concave up is positive? It's going to be this side of the curve. So it's going to be like a left-hand hook right there. So the graph of that should look like, or the right hand of it, so it should look like this. Kind of a curved up, but increasing. So that's what, if both those are positive, that's what it looks like. Now what if the first derivative was positive, but the second derivative is concave down negative? So that's going to be the left-hand side of this curve. So my graph should look like that, or something like that. Now, what if the first derivative was decreasing and the second derivative was concave up positive? Well, then you're looking at the left-hand side of this parabola shape. So I'm going to look like something going like this. So like the left-hand side of a concave up. This is decreasing and positive. Wait, this should be negative. Negative. So it's going to be concave down. And if it's concave down and decreasing, we're talking about the right-hand side of this concavity. So the shape should look like that, kind of decreasing and concave down. So use these as a guide to figure out what shapes of derivatives look like. So we might also do something called graphing antiderivatives. So kind of going backwards. And this might be a little weirder. So maybe we have a graph of f prime and we want to graph f. So how do we do that kind of stuff? We want to make some number lines for f prime and f double prime and use those in combination to figure out what's going on. So some ways I want to show you what this looks like. When I say number line, it's basically like our tables. It's going to be my f prime number line, f double prime. So I'm going to sketch a cubic equation here. Cubic equation might look like something like this. Okay, something going like this. And I want to sketch out a number line for f prime and f double prime. Well, the derivative, this is the function f. The derivative of f is just the slope, so we know we have a relative max right here. So this is going to be 0 at x equals 2, and relative min, let's say right here, that's where it's meant to be, and that's also going to be 0. Well, in between those parts, I want to know what f prime is going to be. Well, in between this side, f prime is increasing, so f prime is positive, and here it's decreasing, so it's negative, and here it's increasing, so it's positive. Now what's f double prime doing? And just a rough idea from this case, well, there's a point of inflection. You see this is like concave down. And this part's concave up. And you're like, well, where does it switch? Halfway in between somewhere. Let's say it switches right here. So right here, we're going to call that our point of inflection where it's 0. And on the left side, we have a concave down shape, so I'm going to say negative. And on the right side, we're concave up, so we're going to be positive. So notice here, this kind of breaks us up into four groups. This is a positive, positive. This is going to be like negative f prime, positive, or negative f double prime, and so on. So we're going to use that information like recreate graphs. Or we could use that to recreate this graph if we wanted to, like if we had this information first. So here's another example. I have the f prime graph. I want to eventually get to the f graph. So follow me along here, okay? I'm going to do a number line for f prime. Okay, so I'm going to use this number. I'm going to do that, like, is f prime going to be positive or negative? Now looking at this graph, f prime is positive from 3 to 0. So at x equals 0, f prime is going to be positive. And then from 0 to, what's that, 3.5, f prime is negative. All right? This goes up to 3.5. And this goes down to negative 3.5. All right, so that's what that function looks like. Now, what's the second derivative going to look like? Actually, yes, that's true. Now, the second derivative, this is the first derivative. So the second derivative is going to be the slope of the first derivative. We're not talking the concavity of this graph. We're talking the slope of this graph. So from here to about negative 2, it's going to be 0. And at positive 2, it's also going to be 0. Well, the slope, which is going to be positive right here, so the second derivative is positive from negative 3 to 2. And this slope is going to be negative from negative 2 to positive 2. So this whole thing's negative. And then over here, my slope is positive. So it's the slope of the first derivative is the second derivative for the second derivative. So watch that. So how do I graph my graph of f? Well, remember back from that chart, think of this like I'm having 4 different domains here, or 4 different areas I have to sketch. I'm going to kind of break them off like this. I hope you can roughly see this idea. So the first derivative is positive, and the second derivative is positive from negative 3.5, so to positive negative 2. And I'm just going to write this information down right here. This might help. So we have my first derivative is going to be positive, and the second derivative is positive. If you go back to that notes you did earlier, when you have a first derivative positive and a second derivative positive, that's a concave up, so it's going to be like the left-hand side of concave up. So I should have a graph that kind of does like this. Okay? I just drew that. Now, from negative 2 to 0, my f prime is going to be positive, but my double prime is going to be negative. And if the slope is increasing or negative, it's going to be this left-hand side. So I should have a graph that kind of curves up like this. Okay? Let's go to the next part. So from 0 to 2, I have a negative first derivative and a negative second derivative. Negative first derivative is decreasing and concave down, so it should look like this. I'm going to do a curve. I'll just put points right here. It should come back down like this and to 2. And at the end, we have a negative first derivative and a positive second derivative. So negative first, positive second should be like the left-hand side of that curve. So it should look like this. And that's a rough idea of how to do this. Now this example wanted to make it go through 0.01. Well, you could just shift everything down. So like this. And there we go. Now it works perfectly. So that's what it wanted, but the general idea is to be able to figure out this shape from those derivatives. All right? Hope you're confused enough.